a happy ending.
So it does take some liberties. However, hopefully, even though we've been talking about packets and data and IP in fairly abstract terms, at least now you do have some visuals to latch onto as it relates to data actually getting from point A to point B. Are there any questions about the internet or that film? Yes? When it says packets are what? Recycle, that's one of these liberties. That doesn't really happen. You don't really reuse bits. You just recreate them. So I think someone, too, with a lot of that film was having a little too much fun with making their graphics, because kind of it's like, all right, we're done painting the packet. Move on. All right. So, yeah. So a ping of death, actually, so that does relate to something we looked at Monday. When we looked at traceroute, that tool that showed us the path between point A and B, the type of packet we were actually sending is something called a ping packet, or more technically an ICMP packet. And that is a packet that is sometimes blocked. That's why we saw the stars instead of actual IP addresses. And a ping of death is essentially a ping that's bigger than it's supposed to be according to the specification. And years ago in particular, computers were just not designed, some computers were not designed with sufficient error checking. So simply sending a packet, too many bits, over the internet to a server could just cause it to crash because it essentially overflows a buffer. So they've rather fallen out of vogue since. All right, so we looked at HTML. And this is itself just a markup language, not a programming language. But it allows us to start constructing web pages, but only static web pages. Everything we did on Monday, I had to manually type into my text editor, gedit. I then saved it, and then I pulled it up in a web browser. And recall that even though it was inside of my appliance, the appliance is configured just like one of these web servers. So its address locally is localhost. But if we were to give it a public IP address, as you'll be able to do for your final project, then anyone on the internet could actually visit that thing. So recall that we did some fairly simple, if ugly, designs. If I go into the appliance and I go into my jharvard directory, recall that we created this thing called public_HTML. It's a little oddly named, but that's sort of the global standard. Different web servers can call it different things, but most servers do call it public HTML. And then inside of here, we left off with eyes.png, which is a graphics file, and index.html. And the latter is the thing that we actually wrote. And the structure of this, recall, was as follows. At the very top of this file, we had an HTML doc type declaration. So even though it has the open brackets, it's not technically a tag, but that's sort of an uninteresting detail. But all of these other things are, in fact, tags. And the pattern was open bracket, something, close bracket, unless a tag's behavior was to be modified by something called an attribute. And attributes have values. So the general syntax for that was to say open bracket, name of the tag, space, name of the attribute equals quote unquote, and then the value of the attribute. And you could have more attributes if HTML allows you. You could have foo equals bar and x equals y. You simply separate them in this manner by spaces. But you would look to some documentation or online reference to see what are the legitimate attributes for that particular tag. And then we introduced one other thing that syntactically was a little different. And that's because this is a slightly more modern feature of the web. So we introduced a div tag, which is just an invisible division, a rectangle. And these just typically help with layout of a page, even though functionally they're not doing a huge amount here. But if I wanted to make everything inside of this div tag a certain stylization, like make everything red text, well, I can use something called CSS, Cascading Style Sheets. And this is just a slightly more modern language, still a markup of sorts, not a programming language, that allows you to sort of fine-tune the aesthetics of your web page. Back in the day, and frankly, when that movie was made, the only way you could really stylize your page is by saying font size equals quote unquote 1, font size equals 2, font size equals 6, and I think 7 was the maximum size. But these were all relative. And folks like Netscape and Internet Explorer and other browsers just kind of arbitrarily decided that font size 6 will be, 48 point. And font size 2 will be 10 point. But it was completely arbitrary. And so if you pulled up a web browser to visit some web page and then looked at that same page in a different browser, it might look very, very different. So CSS was introduced for, among other reasons, to try to standardize the aesthetics of web pages and make it a little easier to structure them. So the pattern that is followed for these things called CSS properties is that they generally go in between quotes as values of the style attribute. So the style attribute's a little special in that you can put almost anything you want in these quotes from CSS. And CSS says find the name of the property, colon, and then the value of the property. So syntactically, this is like mixing one language inside of another. So it's a little odd at first, but we're about to introduce a third language today. So realize that what might still look like Greek actually just gets a little more familiar over time. And in fact, anytime you want to pick up some more tags, it really will be as simple as Googling, looking up one of the recommended resources on the course's website. We're not going to introduce you to all of the possible HTML tags because it's just not all that interesting. In fact, all what we have here is pretty much representatives of all of the HTML tags because we have the nesting idea where this is the unordered list with a list item. We have a tag within a tag here with this anchor tag. We have hyperreferences for links. We have images. So we have at least some of those most popular features of the web. And even some of these do have attributes. And then the anomaly, recall, was this guy, the BR for line break tag. And he was anomalous because he didn't have what? He didn't have a close tag. And you could put it there. That would be OK. It just looks or feels a little silly. You might see this. But again, this is sort of conceptually silly because it's a line break. It's either there or not. It's some atomic concept. It doesn't start and then end. So you don't really need this. But realize you might also see it written as this, which is also OK. You might see the slash at the end of the tag, but inside of it. And this, too, would be called an empty tag. But for HTML5, the latest version of HTML, folks decided that some of these conventions were just unnecessary typing. So let's just say open bracket BR, close bracket. And how do you know this? Honestly, you consult the manual. You consult some resource. And in problem set 7, we'll point you at some specific ones. And the resources page already has a few of those. So this, then, is sort of a canonical web page. It is valid in that it's all correct. It's indented, which means it's nicely readable. And know that we could do this. If we wanted to check our web page, I'm going to go ahead and copy this HTML. I'm going to go to validator.w3.org, which is the website of the standards organization, a bunch of volunteers who essentially try to standardize the web in various languages. And you can see that you can validate by something called a URI, which is just sort of a more general URL. It's essentially synonymous for our purposes. You can validate a file by uploading an HTML file, or you can validate your HTML by directly inputting it. So I'm going to go ahead and just paste this in here. So notice I've just pasted in the contents of a web page. I'm going to go ahead and click check. And what's nice about this tool, and what will be very handy for problem set 7 and 8 in the final project, is it's a nice little sanity check. It will literally check your code and say, yes, this is good in green, or you have some issues. And if you have some issues, you can scroll down and actually read what those issues are. But realize that you're not going to be able to use the validator and tell it that the URL of your page is http://localhost/j_harvard. Because again, localhost is on your own machine. It's not on the internet, which means some website like that can't access it. So realize that dichotomy there. All right, so let's make a slightly fancier web page. And notice that what I've introduced here is just a couple of more tags. I've got my body tag, but inside of it now, I've got some anchor tag and some h1 tag. So the anchor tag, just for demonstration purposes, just has an empty href. I don't really care what the URL is, so I omitted it. H1 stands for heading 1. And historically, heading 1 made text on a page big and bold. What big means was not well defined. It might have been 48 point. It might have been smaller, might have been bigger. So here, too, is why CSS was invented. So we have two tags, though, inside of the body. And the point of this little snippet is to say that you can maybe kind of start to think of this now as a tree, a data structure. The indentation is for aesthetic purposes and readability. But if you think about it, ignore the doc type at the very top and focus only on the HTML element. HTML says there can only be one root element, so to speak. And that element must be called HTML in all lowercase. Open bracket, HTML, close bracket. And now if you look to the right and below it, everything is indented. But this indentation kind of suggests a hierarchy. Right? The children of HTML, if we infer from the indentation, seem to be tags called head and another tag called body. And so we can actually think of the HTML tag, or let's call it an element now to make it more like a data structure. The HTML element has two children, head and body. Body, in turn, has two children, the A element and the H1 element. And if we really want to get technical, even the h1 element has a child. But it's just a textual child. It's literally the string my space header. But we can think of that now as a tree. So even though we've kind of written this top to bottom, left to right, we could redraw it either on paper or in memory as a more familiar tree structure. So not a binary tree. It's just a coincidence that some of these things have 2 children. Certainly a web page can have any number of children. But if we kind of sketch this out as a tree, first I just need some special node at the very top for reasons we won't get into now. But the one that's important is this so-called root element called HTML. It has 2 children, so I drew 2 lines from over to the left to the right. One is for head, one is for body. If we then look at head, the head element has one child called title, and the title element has one child, a textual one, whose value is just quote unquote my title. And over here, body is the same kind of story. Has 2 children, A and H1. Each of them has one child. But notice this href. Why, even though this is an arbitrary picture, this isn't any kind of standard way to draw something, why, though, did I draw probably this attribute called href off to the left and not below the anchor tag? I feel like there's some murmuring here. So just, yeah. Yeah, because it's like kind of part of the A tag, and it's definitely not a child, right? It's not a tag unto itself. It's not below it and indented. So we at least need to draw it in some other way. And this is important only insofar as you think about how to implement this in a programming language. If we are actually going to implement, God forbid in C, a web page like this, we could actually create something called a node, using a typedef and a struct. And inside of that typedef struct would have to be maybe the name of the element and maybe one or more pointers to its children, but then also the notion of one or more attributes as well. So this picture should conjure up at least potential design opportunities here, even though in practice we're not going to use C with regard to the web. Rather, we're going to use a language called PHP. But when we get to JavaScript in a week or so, this picture will actually become quite compelling, because JavaScript itself is a programming language that's going to run inside of a browser that will write this code, and it's going to manipulate the so-called DOM, Document Object Model. So this tree that's depicted here, henceforth we'll refer to as a DOM. And what's nice about JavaScript and what makes today's websites so sexy compared to what they were 5 and 10 years ago is because using this programming language called JavaScript, you can take a tree like this and insert new nodes and remove nodes and move things around and make the website much, much, much more dynamic, right? Case in point, we've all kind of gotten fairly used to something like Google Maps. And if we search for 33 Oxford Street, Cambridge, Mass, and hit enter, a few interesting, but things just happen that we now take for granted. One, there's clearly some autocomplete going on. And my own computer definitely doesn't know about all possible 33 Oxford Streets in the world. So there's definitely some client-server interaction going on there. What does that mean? There's a bunch of HTTP requests that just went from my browser to Google and back, and they were giving me these little hints. But what's compelling about this interface, recall, is that it's not reloading. Right? There's still a lot of websites out there where if you want to see more content or look something up, you click like a submit button or you click a link, the whole page goes white for a moment, and then something starts spinning in your toolbar, and then bam, you see the results. And then you hit the back button or click another link. Right? These websites are becoming increasingly user unfriendly because the bar has been raised by sites like Google, because Google's using a technology called AJAX, which is the use of JavaScript among other things. And even this, right? You might not recall using something like MapQuest, which was one of the first map tools out there, or even Yahoo Maps, where if you wanted to go up or down or left or right, you click a stupid arrow, and then that part of the map reloads, and then you click it again and click it again. And just a few years ago, it was a really powerful thing when Google started actually letting you click and drag so that the whole website is not reloading, just the contents of this frame. And now there's even Google Earth, which makes things even more fancy and more 3D and interactive. So the web is really getting much, much more interesting. So over the next couple of weeks, we're going to learn how these things work and how you can make them do your own bidding. So without further ado,